Absolute value equations appear throughout calculus. Remember, I said that f of x is equal to the absolute value of x. Means that the function is equal to x for all x greater than 0, greater than or equal to 0, and it's equal to minus x if x is less than 0. And of course, this graph looks like these two lines here that meet at the point 0, 0. Now suppose I give you a function like this. The absolute value of x minus 1 is equal to 3. The first thing you need to do is to find the 0 of this. And the 0 of this is when x minus 1 equals 0 or x equals 1. This will be what you use to break your function, your absolute value function, into a piecewise function. So the next thing you need to do is write x minus 1 is equal to, and now write your piecewise function. It's equal to x minus 1 when x is greater than or equal to 1. It's equal to minus x minus 1 for x less than 1. Now, the next thing you need to do is to solve this equation using these 2 points of the 2 pieces of the graph. So for any x greater than or equal to 1, we're going to see if we have a solution to x minus 1 is equal to 3. So x is 4. Indeed, 4 is greater than 1, so this is a solution. What about for x less than 1? I have negative x minus 1 is equal to 3. So negative x plus 1 is equal to 3. Negative x is 2, or x is negative 2. Negative 2 is indeed less than 1, so I have a second solution. Now, for this problem, we can do the exact same steps, or we can do an inspection. So by inspection, the smallest the absolute value function can be is 0. So if this equals 0, there's no way I can get 5 to equal 0. Or you can rewrite it like this. Absolute value of x plus 5 is equal to negative 5. If you ever get an absolute value equal to a negative, you have no solution. Now let's do a complicated one, a more complicated one. I have 2 separate absolute values. What you need to do at this point in time is break both of these up into their piecewise functions. So the absolute value of x is equal to x for x greater than or equal to 0, and it's equal to negative x for x less than 0. The second function, the 0 here is going to be when x equals 1. So the absolute value of 2x minus 2 is equal to 2x minus 2 for x greater than or equal to 1. And it's equal to minus 2x minus 2 for x less than 1. Now, at this point in time, I strongly recommend you do a number line. That's not a real good number line, is it? Okay. And the first thing we're going to do is look at this one right here. When x is 0, okay, so this is 0. So what this function right here is x when x is greater than 0, and it's negative x when x is less than 0. This function right here has a breaking point at 1. So I'm going to put this one down here. So it is 2x minus 2 for all x greater than 1, and it is minus 2x minus 2 for all x less than 1. And I'm just going to kind of put my arrows here. All right, so I can see. Actually, I'm going to go and rewrite it, this one. All right, so you see basically, I don't want to write that in there. I have 3 different segments I need to work with. So the absolute value of x plus the absolute value of 2x minus 2 is equal to, and this is going to have 3 branches. It's equal to x plus 2x minus 2 for all x greater than or equal to 1. Now between 0 and 1, and it's probably better if I write this, minus 2x minus 2. All right. In class, we use a lot of arrows. What is it going to be equal to? It's equal to the top function, which is x, minus 2x minus 2 for all x between 0 and 1. Now, what about when x is less than 0 or less than 0 down here? Then it becomes negative x minus negative 2x minus 2 for all x less than 0. All right, so now in order to do this, let's break it up. For x greater than or equal to 1, and don't worry too much about where I put those greater than or equals in these. We'll look at the endpoint behaviors in class more closely. All right, so I have x plus 2x minus 2 is equal to 8. I'm going back to my original equation. So I have 3x is equal to 10. X is equal to 10 thirds. 10 thirds is indeed greater than 1. So I have a solution. Let's go to x between 0 and 1. All right, I have x minus 2x minus 2 is equal to 8. So this is x minus 2x plus 2 is 8. So I have minus x is equal to 6, or x is equal to minus 6. Now minus 6 is not in 0 to 1, so this is not a solution. So that happens. Now finally, let's look at this last region. For x greater than 0, I might run out of room here. Oh, excuse me, for x less than 0, I have minus x minus 2x minus 2 equals 8. So I have minus x plus 2x plus 2 equals 8. So I have x is equal to 6. Did I do that right? Oh no, I don't have a minus sign there. Yeah, y'all don't do that. Don't make algebra mistakes. Got carried away. Carried my negative in too soon. So this is negative 3x is equal to 6, or x is negative 2. Now you see when you follow this x is indeed less than 0, so this is a solution.